Hello everyone, welcome back to Labtube. In this video I'm going to discuss about a problem from section 16.2, problem 4, which asks to evaluate line integral. That line integral over the line segment going from 20 to 54. Okay, first let me recall quickly how we evaluate line integrals. If let Rt be a parameterization for the curve C, okay, for what values going from A to B? T goes from some number to another number, then integral of f c ds is nothing but we have to apply 3 steps to get a regular integral and then evaluate that. First thing is put the boundaries for t in your integral. Second thing is plug in new variable in your function, meaning that your function, the variables of your function, you plug in Rt in that. Then the third step is find your integral line in terms of new variable, which is given by find derivative of r, find the length of that, then multiply by dt. So those are the steps we have to apply. Now, in this case, this means practically for us means that we have to find the parameterization. So what is the parameterization of the line? What is a parameterization of the line segment from this point to that point? You know how to find the equation for line in R2, R3 using one point and one vector showing the direction. In general, what you can do is you put first point here plus t times end point, which is 5, 4, minus initial point. And that gives you 2, here I have 5 minus 2 is 3, plus 3t, and 0 plus 4 minus 0 is 4 times t, 4t. If you parameterize your line using this formula, then the values for t is going to be from 0 to 1. If you plug in t equal to 0, you won't have this part, you will get the starting point. If you plug in 1 here, this will cancel with that and you will get the end point. So that's how you parameterize. Now, I have RT, parameterization, I have boundaries, I have to apply these steps. But before I go there, let's find R prime. So R prime t is going to be partial derivative of this guy and derivative of this guy with respect to this. This is 3, 4. And I need its length, which is given by 3 squared plus 4 squared, and it is equal to 5. Now everything is ready. I have my f here is x e to the y. So if I want to plug in everything, let me apply all those 3 steps. First is boundaries. Boundaries, t goes from 0 to 1. Second step is plug in everything in f. So what does it mean? It means that for x in your function, you plug in 2 plus 3t, and for y, you plug in 4t. So then I will have 2 plus 3t times e to the power y is 4 That's the second step. And third step is put the right integral element in your integral, which is length of r prime. In our case, it is 5 times dt. Okay, now everything is ready to go. It is 2, I multiply everything. 5 times 2 is 10 e to the power 40. And this guy here is 15 t e to the power 4t. Okay, so here now I have to integrate this thing, find antiderivative of this. If it was e to the t, I would put e to the t, but now it has 4 there, so antiderivative of e to the 4t is 1 over 4 e to the 4t. To find antiderivative of this, you have to do integration by parts. So let me just write it here. Integral of 15t e to the 4t dt. If you do apply integration by parts, you're going to get 15 over 4 t minus 1 e to the 4t. So I can put here 15 over 4 t minus 1 e to the 4t, go from 0 to 1. And now fundamental theorem of calculus, just plug in upper one, 10 over 4 e to the 4. 4 times 1 is 4, plus 15 over 4, 1 minus 1 e to the 4, this is 0, minus, now I can put a 0 there, so it is 10 e to the 4 e to the 0, plus 15 over 4, 0 minus 1 is negative 1, e to the 0. You can simplify this thing. So this is 0, this is 1, this is 1, and we get, this is 10. 10 over 4 e to the 4. And here I get 10 over 4 minus 15 over 4. It is negative 5 over 4 plus 5 over 4. So, very quick wrap up again. If you have a line integral, first step would be parameterize your curve. We did that, it was a line. And then you apply those 3 steps. First, new boundaries for your function, for t, for your parameter. Plug in new variable in your function, meaning that your rt has x, y, z in terms of t, you plug in your function. And third step is find your line element or integral element in terms of your parameter. When you do that, which we did here, then the remaining was just a regular integration. You just do regular integration, fundamental theorem of calculus, and that's it. Thank you for watching this video.